At the end of this video, you should be able to use dimensional analysis to check the validity of equations and perform order of magnitude calculations. Chapter 1, Section 3, Dimensional Analysis can weed out invalid equations. Suppose a car, such as the one in Figure 3.5 on page 25 of your text, or on the screen now, is moving at a speed of 88 kilometers per hour, and you want to know how much time will it take to travel 725 kilometers. How can you decide a good way to solve the problem? You can use a powerful procedure called dimensional analysis. Dimensional analysis makes use of the fact that dimensions can be treated as algebraic quantities. For example, quantities can be added or subtracted only if they have the same dimensions, and the two sides of a given equation must have the same dimensions. Let us apply this technique to the problem of the car moving at a speed of 88 kilometers per hour. This measurement is given in dimensions of length over time. The total distance traveled has the dimension of length. Multiplying these numbers together gives the following dimensions, shown on the screen now. Clearly, the result of this calculation does not have the dimensions of time, which is what you are calculating. This equation is not a valid one for this situation. To calculate an answer that will have the dimension of time, you should take the distance and divide it by the speed of the car, as is shown on the screen now. In a simple example like this one, you might be able to identify the valid equation without dimensional analysis. But with more complicated problems, it is a good idea to check your final equation with dimensional analysis before calculating your answer. This step will prevent you from wasting time computing an invalid equation. Order of magnitude estimations check answers. Because the scope of physics is so wide and the numbers may be astronomically large or subatomically small, it is often useful to estimate an answer to a problem before trying to solve the problem exactly. This kind of estimate is called an order of magnitude calculation, which means determining the power of 10 that is closest to the actual numerical value of the quantity. Once you have done this, you will be in a position to judge whether the answer you get from a more exact procedure is correct. For example, consider the car trip described in the discussion of dimensional analysis. We must divide the distance by the speed to find the time. The distance, 725 kilometers, is closer to 10 to the third kilometers, or 1,000 kilometers, than it is to 10 to the second kilometers, or 100 kilometers. So we'll use 10 to the third kilometers instead. The speed, 88 kilometers per hour, is closer to 100 kilometers per hour. So we can deduce that this trip will take about 10 hours. This estimate indicates that the answer should be closer to 10 than it is to 1, or to 100, which would be 10 to the second. The correct answer, which is 8.2 hours, certainly fits this range. Order of magnitude estimates can also be used to estimate numbers in situations in which little information is given. For example, how could you estimate how many gallons of gasoline are used annually by all the cars in the United States? To find an estimate, you will need to make some assumptions about the average household size, the number of cars per household, the distance traveled, and the average gas mileage. First, consider that the United States has about 300 million people. Assuming that each family of about 5 people has 2 cars, an estimate of the number of cars in the country is about 120 million. Next, divide the order of magnitude of the average distance each car travels every year. Some cars travel as few as 1,000 miles per year, while others travel more than 100,000 miles per year. The appropriate order of magnitude to include in the estimate is 10,000 miles, or 10 to the 4th miles per year. If we assume that cars average 20 miles for every gallon of gas, each car needs about 500 gallons per year. Multiplying this by the estimate of the total number of cars in the United States gives an annual consumption of 6 times 10 to the 10th gallons.
Dimensional analysis and estimation help you to check the accuracy of your calculations. Suppose we are about to take a trip to a city 725 kilometers away. We expect our average speed to be 88 kilometers per hour. How long will the trip take? We first verify that we have set up the equation correctly by making sure the dimensions of the answer are what we expect. Only one combination of speed and distance will have the proper dimensions to give us the time. Does time equal speed times distance? No. Does time equal speed divided by distance? No, but since the dimensions of speed divided by distance worked out to 1 divided by time, we next try the inverse equation. Does time equal distance divided by speed? Yes, this equation gives the correct dimensions. To estimate the answer, we make an order of magnitude approximation by rounding each quantity to the nearest power of 10. We find that the trip should take about 10 hours. An exact calculation shows that the trip would actually take 8.2 hours, a number in keeping with our estimate and having the proper dimensions and units.
At this point, you should be able to use dimensional analysis to check the validity of equations and perform order of magnitude calculations.